All right, here we go. So we're on 1.28 rate of change refresh. The reason why it's a refresh is because we've already kind of talked about rate of change, correct? Y'all remember doing that in unit 1.1?
No. Yeah.
Yes, you also just did your performance task. We had to find the change and how did it go, how people were coming in and out, right? Yeah, okay, so it's a refresh. Again, nothing we should be doing today should be new, correct? All right, so you should have written down in your notes on your page 27, the definition of rate of change. So the rate of change describes how two quantities change together, right? One is your independent quantity, the other is your dependent quantity. And we're just looking at how do they change together, okay? The unit of the rate of change is the ratio of the unit of the output, just meaning that whatever your numerator is, your numerator, that's numerator unit is. So if this is inches and this is time, then it's inches per time. Does that make sense? I'm saying like whatever the units are. So whatever the units are in the change. So let's say if my numerator is describing inches and my denominator is describing seconds, then it's inches per second. Does that make sense? That's what this is telling you. That this would then be inches per second. So like on your performance task, you had people per hour, right? How many people were leaving and coming and going per hour, correct? All right. The rate of change of a linear function is also known as the slope. Do you remember that? Okay. For linear functions only, the rate of change is the slope, meaning that I can easily look at the function itself and know what the rate of change is without having to do the math, correct? All that sounded familiar? All right, so we're going to look at a couple examples. We're going to look at it from a table, from a graph, and from a function. But all of these are going to be non-linear. Got it? All right, so starting off, you don't need to write down the whole table. We're just going to read the table and take the values we need from the table, okay? So example 1 that you're writing into your notes, it says using the data in the table, find the average rate of change of the price of gasoline between 2007 and 2009. So the first thing we're going to do is only highlight what we need. So we only need 2007 and 2009. That's it. You're only highlighting from where you begin to where you end. Got it? The middle doesn't matter, okay? You're only highlighting where it starts and where it ends, correct? So now we're going to write it as an ordered pair. So as an ordered pair, we're working with 2007 and $2.84. 2009, gas was $2.41. You weren't even driving. It wasn't even affecting your life. Okay. All right. So therefore, this is going to be my X1, my Y1, my X2, and my Y2. Our AROC, our rate of change, our average rate of change, equals, this is delta Y over delta X. So change in Y over change in X, which means that all we're doing is Y2 minus Y1 over X2 minus X1. You don't need to write this down unless you just don't remember it. And now we're just going to follow the formula, right? Your Y2 minus your Y1, your X2 minus your X1. Okay, so I'm going to do it. I'm going to do it at the top so you can see it. So we have 241 minus 284 over 2009 minus 2007. That's 7. We're going to commit to it. All right, what's $2.41 minus $2.84? It's going to be a negative 43 cents. And what is the year span between 2009 and 2007? 2. So from here, my units are cents and years, right? Okay. So we know that this is in cents and this is in years. This is the the exact value. To find our answer, we're going to plug that into a calculator. So anyone want a calculator? Can you plug in for us? Negative 43 hundredths divided by 2 and tell us what is our average rate of change in the price of gas between
Negative 0.215.
1.5? So the gas prices are declining, and I'm going to put it in terms of cents. Decline by about 22 cents. 22 cents. I'm writing bad math all around. I need a dollar sign. And do not like the dollar sign. There we go. Please don't be those people who put your dollar sign after the money. It's weird. So negative 22 cents per year. And then after 2009, what did you notice? It stopped declining and did what? It went shoot, right back up.
I wish I was driving in 2009.
I was not. No, I had a fear of driving then. My family drove me everywhere. I was fine with it. All right.
Were they?
I don't know. Didn't
They
matter.
didn't have an option.
All right. Good. Can we do it from a table? Anyone's like, I cannot do it from a table. Oh, I was like, what? All right, now we're gonna look at it from a graph. So on a graph, you're gonna have to read the graph, identify the points, and go from there. Okay. So now here's our graph example. It says it gives us our interval. So our interval is from -1 to +2. We see that? So only values we got to find are -1 and 2. +2. So I'm going to go to -1 and I get what? 4. So I know I have -1, 4. I'm going to go to 2 and I get 1. So we have 2 and 1. So this is my x1, y1, x2, y2. Can I easily find the AROC? It is. That's why it's just a refresher. So 1 minus 4 over 2 minus -1. And we get -3 over 3, which equals -1. Okay. Easy peasy from a graph function. So we had table, graph. Now we're left with our function. Questions about graph? No? Okay. Last. Here we go. The average rate of change of the function f of x equals x minus 2 square root of x on the interval from 1 to 9. I wonder why we had to do problem trails. Because we need to make sure we can find our values, right? Okay. Exactly. So the first thing I'm substituting in is 1. So f of 1 equals 1 minus 2 square root of 1. And what do we get? What's the square root of 1? So 1 minus 2 is? -1. So f of 1 equals -1. So that means my ordered pair is 1, -1. Are we good?
Yep. Well, great.
All right. Now we're going to do f of 9. Same thing, right?
Oh, those are both.
These are x and a y.
No, I'm saying 9.
Your interval is always x values. Your interval is always x values. So we have 9 minus 2 square root of 9, which gives us 3. 2 times 3 gives us? So 9 minus 6 is? +3. So f of 9 equals 3. So it's an ordered pair, that's going to be? 9, 3. Do I have everything I need to find my rate of change? Find my rate of change. And that concludes our notes.
I hope you never have to find out as well.
Why?
It takes too long.
It wasn't even hard, Randy. Right. Let me know if you need me.
If it's a minus, it's a negative.
It's a positive. A negative times a negative makes a
Or if it's
negative,
a-
negative.
A positive times a negative.
Are you subtracting or you said a minus minus?
Yeah.
So a minus a negative is plus a positive.
So I got.
What do you mean?
I don't know where I got that. So bad.
All right.
Yes. You need the input now.
Are we ready? Huh? You cut your hair off?
I just got my hair off.
Okay. All right, let's see what we got.
Then I just close.
Okay, that's for you too. So my Y2. So to determine your X1 and your X2, it's always just left or right, what comes, right? So this is gonna be X1, Y1, X2, and Y2. All honesty, it will work itself out in the end as far as positives and negatives. Okay, so we should have 3 minus -1 over 9 minus 1. Minus a negative is plus a positive because a negative times a negative makes a positive. So 3 plus 1 is 4. 9 minus 1 is 8. So our rate of change is
2/4.
just 1/2.
2/4. And 1/4.
Yeah, eventually it was going to get down there, right? All right, so we've now done all three. Can you tell me from a table, a graph, a function? Yes? We got this? All right, because I just want to make sure, because if you have a quiz over this on Monday, will you be fine? If you read your agenda, it told you also.